Yeah, good morning, everyone. We will start.
Good morning, ma'am.
ಅವ್ರ ಬ್ಯಾಲೆನ್ಸ್ ಇಲ್ಲ.
Okay, should we start?
Yes, ma'am.
Okay. Now we are learning the last unit of your syllabus, which is about network management and security services. Now I had told you providing security to your network and the messages and the contents that are being transmitted over the network is of utmost importance, because the data that we are transmitting could be really confidential. We do not want intruders or malicious users to get access to the network, and we do not want our data to be misused, data to be corrupted. And that's why providing security to your system, to your network, is very important. Yesterday's class, we had learned this particular diagram where I had told you security services could be looked at from 2 points of view: from the point of view of the message, that is the actual data that we are transmitting, and from the point of view of entity. Entity is the person or the client or the user who is trying to send the message. So when we look at the security services from message point of view, we have 4 aspects of it, that is message confidentiality, message integrity, message authentication, and message non-repudiation. Okay, we had learned among this message confidentiality and message integrity. Today we will learn about we'll also learn about message authentication. Today we will be learning about digital signatures, which is a part of which is a part of message authentication, and we will also learn about entity authentication. Okay. So yesterday we had learned all this. Today we are going to learn this particular concept, which is called as digital signature. Now, you people must have come across this word called as digital signature. Everybody knows what is a signature, isn't it? Whenever you have a official document or you have certain bank related documents, you are expected to put your signature there. Now, what does a signature signify? A signature signifies that the document is authentic and it has come with your consent. The contents of that particular document are consented by you. So many a times when we are sending emails, when we are doing some official transactions over the internet or maybe over a network, it may be necessary to check whether the message has got a signature. It may be necessary to check the authenticity of the message. And hence, a kind of a concept is used which is called as digital signature. We are going to learn about digital signature and how it is applied to a particular document. But before that, we will try to understand the difference between a conventional signature and a digital signature. Now, conventional signature means signature that you do with a pen on a piece of paper. You tend to put your initials or you have a unique way of signing a particular document, which signifies your authenticity. Okay, that is called as a conventional signature. And digital signature is one which we attach or which is which could be used for authenticating a particular document or maybe an email, and we call that as a digital signature. So we'll try to first understand the difference between conventional signature and digital signature. The conventional signature is included as a part of the document. For example, suppose you have a mark sheet. At the bottom of the mark sheet, there'll be a principal signature or there could be the registrar's signature of a particular university. What does it specify? That it specifies the authenticity of that particular document. So conventional signature, which you do with the pen, is included inside the document. But digital signature is not included inside the document. It is not a part of the document. See the second difference. In the conventional signature is a part of the document, but here digital signature is not a part. Digital signature is sent as a separate document. It's not included as a part of document. Example of conventional signature you can see when we write a check, a bank check. The signature is on the check. It is not a separate document. We don't have a check as a different document and a signature as another document and then we staple the two and send. No. We have a check. At the bottom of the check, we put our signature. So signature becomes a part of that document. Whereas in case of digital signature, the receiver is going to receive two documents, the original document and the digital signature document, which is sent by the sender. With the help of digital signature, the receiver can verify the sender, and if it is proved that the sender is authentic, the message can be kept, otherwise it can be rejected. So most important thing that you'll remember is conventional signature is a part of the document. Digital signature is not a part of the document. Then we will see the second difference between a conventional signature and a digital signature in terms of verification. In conventional signature, when the recipient, that is the receiver, receives the document, he or she will compare the signature on the document with the signature on the file. For example, say a bank, okay? Suppose you have written a check and you have put your signature down. When you send the check for, to be cleared to the bank, what the bank officer will do? He will take that check generally. If the person or that customer is usually known, then no need. But then general procedure is the bank officer will take the check, verify the signature with the specimen signature which the bank is having, which is taken well in advance, which is taken prior, and then those two signatures are, they are going to be verified. So signature on the document is verified with the signature which is stored in some file. Whereas in digital signature, the recipient receives the message and the signature. The copy of that signature is not stored anywhere. Okay, so in case of digital signature, the recipient needs to check whether you needs to have a verification technique to for the combination of the message and the signature to verify the authenticity. In conventional signature, it's very easy. The specimen signature which is there in a particular file and one which is there on a check or maybe some other document, we can verify the two and see whether they are same or not. If they're same, it is authentic, otherwise it is rejected. But digital signature, it is not like that. The signature is not stored anywhere. It's one time signature sort of. Okay, so if the recipient, the receiver should have some method to verify that signature and know whether that document and the sender is authentic or not. Okay, then one more difference between digital signature and conventional signature. There is, in conventional signature, there is one to many relationship between signature and document. For example, a person has a signature that is used on, he can use, I mean, once you have decided your signature, you will use it officially everywhere on your bank maybe documents, on checks, on official documents. It could be on anything. Everywhere the same signature is going to be used. So it is one to many, one signature used at many places or on many documents. Whereas in digital signature, there is one to one relationship between signature and a message. Every message has its own signature, means the signature cannot be reused, or signature is never going to be used again and again for the message. Once a signature is created, it is only for one message. Next time, new signature has to be created. So you understand this. Many a times what happens, students get confused. Students feel that digital signature means, scanned signature. Suppose my signature is ASD. Then I can take a camera or I can take a scanner, I can scan it, and that image I apply to my email ID or maybe to the email that I write, and that becomes a digital signature. No, that is not a digital signature. It is a scanned signature, a digitized signature of your regular signature. That is not what we are talking about. Digital signature here means creating a kind of a method or a pin or a way to authenticate the sender, to check the authenticity of the sender. So you have to remember this very important point, or the last point. That is, in digital signature, there is one-to-one relationship between signature and the message. Each message, suppose I'm sending one particular message or an email or maybe some content from sender to the receiver. First time I send the message, some different signature. Next time the signature is going to be different. Again, next time the signature is going to be different. So every digital signature always has one-to-one relationship. It can never be reused. Whereas a conventional signature, which you do with a pen, there's no question of reusing it. You have to do the same signature every time. If you do a different signature, then maybe your signature will not be taken as an authentic one. It will be assumed that it has been forged. Okay, so we will now try to understand the process of digital signature. Now, what do we mean by digital signature? Digital signature means to create a sign or a signature for a document. The signer, that is, say, a sender, will use his private key. Yesterday also I was telling you that a key is nothing but a unique number. So private key means it is known only to the sender. It is not known to the receiver. So what the sender is going to do, the sender is going to use, will have a document or a message to be sent. The sender will sign using his private key. That is, he will apply his private key. Along with that, he will also apply the signing algorithm, because we need to convert that message. Otherwise, it will be available to everyone. It will be accessible to everyone. So a signing algorithm could be something like an encrypting algorithm, which creates that digital signature. Okay. Then this is at the sender side. So at the receiver side, what has to, the receiver has to do? The receiver has to verify the document. So the receiver will verify the document using public key of the signer. So there are going to be two keys. One is private key, one more is public key. Private key will be used by the sender or the signer, and public key will be used by the receiver or the verifier. So verifier uses the public key of the signer, applies the same just like there is a signing algorithm at the sender side, there's going to be a verifying algorithm at the receiver side. Then both are going to be matched. Only when they are matched, the digital signature is assumed to be authentic. Now, digital signature can be achieved in two ways. There are two ways of doing digital signature. One is called as signing the document, and second is called as signing a digest of the document. Instead of signing the actual document, we sign its digest. Just like the method that we learned yesterday. We are going to learn both, okay? Now, first method is signing the document. Signing the document is the same thing what I told you just now. That is, whatever document or the message that a sender wants to send, it is encrypted, it is signed with an algorithm and along with a private key of the sender. So you can look at this diagram. Let us say Alice is a sender. Alice will have her own private key. She will generate, I'll just make use of these annotations here. Yeah, so Alice is the sender. She will have her own private key. Whatever message she generates is called as plain text. To that plain text, the encryption or the signing algorithm is applied, and also the private key is applied. Now, once this is done, the document is said to be signed, and now it is transmitted to the receiver. Once it goes to the receiver or the verifier will make use of decryption or the verifying algorithm, then also apply what we call as the public key. So here private key is applied, here public key is applied, and what is obtained now is the plain text which is received by the receiver. Okay, so this method where we take the document, apply the private key, apply the encryption algorithm, send it. At the other side, verification is done and a public key is applied. Public key will be known to both Alice as well as Bob, that is both to the sender and the receiver, and the original document is obtained. This we call it as the signing the document. Another way of doing it is, instead of signing the document, we can also sign the digest. Now, signing the digest means what? We don't actually sign the original document, we create a digest of it. So what is meant by a digest? Yesterday also I was telling you, the original message, to it a mathematical function called as a hash function is applied and a digest is created. Okay, so here we are going to have a one-to-one relationship. A carefully selected message digest has one-to-one relationship with the message. That is, the sender can sign the message digest and then the receiver can verify the message digest. All of you have a look at this diagram. This is similar to yesterday's method. Suppose we have two parties, Alice and Bob. Alice is a sender. Okay, so while sending, while creating the digital signature, she doesn't do it for the document. She creates a digest of it. So how does she do it? Alice will take her original document, apply a hash function, and also apply a hash function to generate a digest. To this, what is being applied is her private key. So now two things are there, the digest as well as the original message. The digest along with the original message, that is the message and the signature together, are sent to the receiver. Now the digest is made available to the receiver, the original message is also made available to the receiver. So what the receiver or Bob will do, he will take the original message, he will also apply the hash function and generate the digest. Now he is going to compare the digest sent by the sender along with the digest that he has generated. If both are same, then he will accept that digital signature and the message. Otherwise, he is going to discard. So understand the difference between signing a digest and signing a document. See, when we are signing a document, it's quite easy. What we are doing there, in case of signing a document, what we are doing is take the original data, apply the algorithm, private key, create the signed document and send. At the receiver side, public key, decryption and receive. Okay. Whereas if it is a digest, now you may wonder why do we need a digest if we already have a method for signing the document? See, sometimes the messages are very, very long. That time, creating applying a assigning algorithm to the original document may sometimes be cumbersome or not so efficient, and that's why signing the digest is used. So signing the digest means what? Take your message, apply hash function, generate a digest, to it apply a key, a public key, send it to the receiver. The receiver will get the digest as well as the message, apply the public key, keep the digest separately, get the message. Now to that message, the receiver will apply the hash function and generate his own digest. Now if the sender's digest and the receiver's digest both are same, then accept it, otherwise he will discard it. Okay. Now we will have a look at what is meant by entity authentication. Now usually entity means what? The user or a person or sometimes a client machine or a process. It can be anything. Okay, in a network, it could be a person, a process, a client, or a server. That is a machine or maybe a human being also. So entity authentication means what? Entity authentication is a method or a technique which is used to let one party prove the identity of other party. Means if I want to know, if I'm a receiver, I want to know whether the sender is a correct sender or an authentic sender or not. I have to prove the identity. So it could be either the sender or the receiver. Either of the two parties want to prove the identity. That technique used to prove identity is called as entity authentication. As I said, an entity can be a person, a process, a client, or even a server. Then we should know who is a claimant. The entity whose identity needs to be proved. For example, suppose there's a sender and a receiver, and a sender's identity has to be proved. Then sender is called as claimant, and the receiver who tries to prove the identity is called as the verifier. Okay. Now this may sometimes this kind of a verification process is very, very important in digital networks or in computer networks, because you never know who are the hackers. Anybody can impersonate or can create hack into someone else's account and then transmit the data. So there should be some way of authenticating, some way of checking. And for that, entity authentication mechanism is used. Okay. Now, the verifier who will prove the identity of the claimant, who will check whether the claimant is correct or not, will usually go through a process or does a particular process which is called as verification. Now, how is the verifier going to verify whether the claimant is authentic or not? Usually, by making use, generally, he will try to check something that is known, okay, or something that the sender possesses, or something that is inherent. Means something that is known in the sense, for example, with the help of a password will be known. Okay, it may be stored in a database, and from there it can be checked. So something that is known in the sense, we can check with the help of a password, a PIN number, a secret key, or a private. For example, suppose you are using your debit card to withdraw some amount from the ATM. So the moment you go to the ATM, you will put your debit card or your credit card into that slot, and immediately it will ask you to enter a PIN number. Now, why to enter a PIN number? To check whether you are an authentic user or not. Sometimes, stolen credit card or debit cards may be there. Somebody is trying to hack into your machine, or somebody is trying to hack into your account. So how are we going to verify that? By checking something that is known. So what could be known? The password of a particular person. Now, who will know? Only the verifier, only the receiver will know.
PIN number or a secret key or a private key could be something that is known. Similarly, something that is possessed. For example, suppose you are you have won a lottery, or maybe you have won some government schemes, one particular scheme that the government has kept. So you want to claim that amount, okay? You go to the government office to claim that account. Now, how are they going to give you the amount directly? They have to check whether you are an authentic person who has actually won or not. Otherwise, today I will go and say I have won and I get the money, and tomorrow the actual person comes and says I am the one. So the claimant needs to be verified. We have to check. So how can we check whether he's a correct person or not? We can check his passport. Means he possesses it. He has that particular document. His driving license could be checked, or maybe a ID card could be checked, or something like the Aadhaar card could be checked. This is something that he possesses. Okay. Verification can also be done by something that is inherent. Inherent means inherited, a part of your characteristic. For example, your fingerprints, they are very unique, or your voice, your facial characteristics. Do you know the eye, human eye, the retina that is present in the eye is also very unique. It doesn't, it is not going to be repeated. So all these things which are inherent means they are inherited, or they are a part of our genes. Such things we could use to verify a particular person. For example, every day when I go to the college, I'm asked to give my fingerprint, and the timing that I log in is stored in the database. Now, why? So that when I come inside and I give my fingerprint, the system becomes sure that it is me who has actually, signed or logged into our system. Otherwise, anybody's. Earlier we didn't have a fingerprint system, so we had a muster system where we had to sign. Anybody could put my signature. Forgery was easily possible. To avoid forgery, we can make use of inherent characteristics like fingerprints, voice, or facial characteristics, or retinal patterns, etc. Okay. Now, a common method which is used for entity authentication. We want to check whether the person is correct person, whether he's a valid user or not. So for that, we can make use of passwords. Now, when are passwords used? Passwords are used when a user needs to access a system to use the system's resources. For example, you want to access your email ID, or you want to use your laptop, or there's a desktop machine or a server machine in the lab that you want to access. You want to access its resources. Hard disk you want to access. Files stored on the hard disk you want to access. You can do it with the help of passwords. Each user has a user identification that is a public, or that is user ID is public and password is private. User ID means, for example, my email ID asd_bc@yahoo.com. It's public. Everybody knows that email ID, and I commonly give that email ID so that people can send me email. But my password is private. Only I will know it. I'm not going to share it with anyone. So user IDs are public and passwords are private. Generally, passwords are of two types: fixed passwords and one-time passwords. Now, it's very easy to understand. Fixed password means same password you will keep on using for many, many days and many years. But generally, if it is a fixed password, it can be, hackers can hack that password. So generally, it is subject to attacks like eavesdropping, stealing a password, accessing a password, etc. Now, eavesdropping means what? Some XYZ person may try to guess your password. That is called as eavesdropping. So once he guesses the password, then he can apply that password and get access to your email or get access to your resources. So instead of fixed password, especially for transactions which are of utmost importance, like for example, if there are financial transactions that are happening online, then instead of fixed password, generally what is preferred is one-time password, OTP, what we call. Okay, one-time passwords are used only once, means for a particular transaction or for a particular session, they are valid. Next time you want to do the same transaction, new password will come. But the one-time password method is quite a complicated process, because every time the authenticity of the user needs to be checked, then the password needs to be sent, and then you have to log. So that is quite complicated, but it is safer in terms of eavesdropping and hacking one-time password is much better than a fixed password. Okay. All right. What we are going to learn now. Rohan, do you want to ask something?
Sorry, ma'am, by mistake.
Okay. Fine. What we are going to do now is we are going to learn about this last part of your syllabus, that is about what is meant by virtual private networks, VPN. Now, before I tell you what are VPN, that is virtual private networks, first let me tell you what is a private network. Now, the name itself is suggesting private means a network which is to be used inside or within an organization, which is private to organization, not public. Everybody can't use that network. Only the members, the employees of a particular organization can use it. Such a network will be called as a private network. Now, what does a private network do? It gives us access to shared resources. For example, a printer or a scanner or hard disk or some server, some files stored on the server, we can very easily access with the help of private networks. Example is LAN. Okay, a LAN is nothing but a private network. It is for a particular organization. Now, generally, private networks provide privacy. That is, outsiders, that is maybe general public cannot access private networks. For example, we have a private network inside our lab. Okay, only students and staff can access it. Outsiders cannot access it because it is meant to be accessed only inside the network, inside the organization. Moreover, access to that network is not available from outside. That's why also it is private. Usually, private networks are of two types. One is intranet, one more is extranet. Intranet is a private network. Intra means within an organization. It's not inter, it is intranet, not internet. Intra means within an organization, which is limited to the employees of the organization. And if at all necessary, with the help of this LAN or with the help of an intranet, it is possible to make use of web servers, print servers, file servers. Commonly shared resources can be used using intranet. Then there is something called as extranet. Now, extranet is similar to intranet. That is, it is also used by the employees of an organization, but some of the resources may be accessed by specific group of users outside the organization. Means outsiders may be able to access, or you may be able to access some outside resources under the control of a network administrator. It's not that everything we will allow to access or everything we are allowed to access. No, certain resources of the organization could be accessed under the administrator's rights. Suppose the administrator has given you the rights, then maybe outsiders to certain extent can access. For example, an organization may allow authorized customers to access the product specification and for online ordering. Let's take one example. Say, for example, we are talking about Hindustan Lever Limited. Okay, they have their own intranet, they have their own network, and that is used by employees. But to a certain extent, customers of Hindustan Lever Limited, that is, say, for example, me, I want to order some products online. So what I can do, I have access to some part of their website where I can click, I can log in, and then I can choose which all products I want of Hindustan Lever, like maybe Surf Excel or something like that. And after that, I exit. So I am also allowed to access their resources. I'm allowed to access their website for ordering, but only limited access is there. I cannot do anything beyond that as a customer. Now, what is happening here? The intranet, which is for the Hindustan Lever Limited employees, is being made available to me also. That is called as an extranet. Okay. Another example is that a university or a college can allow distance learning students to access computer lab after password has been checked. For example, distance learning means correspondence. Suppose we have one distance learning course in our college, BCA external. So these external students can access our server, but that too only after verifying whether they are actually our students or not. So we are giving them access to certain resources of our lab after checking their validity or after checking their authenticity. Such a network, which not only caters to the internal members of an organization, but also to certain extent outsiders, is called as an extranet. Okay. Then we have something called as hybrid networks. Now, what are hybrid networks? It's a combination of intranet and extranet. Usually, you can't have if you have only intranet, your access become restricted. If you have complete extranet, then outsiders get too much access. So we need to share that balance. So hybrid networks allow an organization to have their own private internet. Private internet means internetworking among private networks. Okay. At the same time, access global internet. Like, for example, the actual World Wide Web could also be accessed. So intra-organization data are routed through the private internet. That is, within an organization, whatever is there, it is routed with through the private internet. And suppose from an organization, I want to send some data to some external network or to some external entity, then it is routed through the global network. So here we are having what we call the win-win situation. That is, within a network, the privacy is maintained. At the same time, if necessary, we can transmit the data outside. So you all can see this diagram. This is site A. Site A, let's call it as an organization A, in which many computers are connected to this ring network. So within, suppose we'll call this, let me just annotate. We'll call this machine as A and this machine as B. Suppose A wants to send something to B, within the organization only it has to be routed through this router one, it can come to this particular machine. Or maybe directly through this network, it can come to this particular machine. But suppose the machine A wants to send something from site A to site B. Site B could be a branch of this particular organization, and that branch is situated very far. So your data has to go from one network to another. Then it is routed through what we call as the internet. Here you have one private network and here you have one public network. Data from a private network is getting routed through a public network. That is why it is called as a hybrid network. Okay. Now, we will try to understand what are virtual private networks. Now, the name itself is suggesting basically they are private networks. But they also give you some advantages of a public network. So virtually they are private networks. They are not truly virtually, they are private networks. Now, we'll try to have a look at what is VPN. Private and hybrid networks have one drawback, and that drawback is cost. So if you have a private wide area network, suppose there are many branches of a particular organization in Delhi, Bombay, Madras, and so on. So we want to connect all of them, and we should have our own WAN, our own wide area network. But that can be expensive. Why? Because we have to set up the cables, we have to set up the media, we need to put up the routers, everything. So if my organization is a very big organization, billionaire, then I can do it. But otherwise, setting up such a big WAN could be costly. To avoid that, we can make use of a virtual private network. Okay. Now, I think we have only 1 minute left. So what I'll do is I'll schedule one more meeting immediately, and I'll share the password with you. It will take 10-15 minutes to finish this. Okay. I'll share it in 2 minutes.
Yes, ma'am.